Hello, Friends Academy, and welcome to our first wonderful Wednesday. I mean, any day with mathematics is wonderful. But Miss Flaherty and I talked, and we wanted to maybe take some time on Wednesday to share just some different things from the usual curriculum, some interesting things, and hopefully some things you may find fun and interesting. So this is our first one. We'll be doing one possibly every Wednesday for as long as we are meeting remotely. There's a few challenges in today's problem. There are some huge numbers of imaginary bonus points available, which we'll get to. But let's go on. And so let's talk about what we have. So the following people here are all writers on a TV show. And the question is, what show do you think that is? I'm not going to necessarily go by the names, but I want you to, for a moment, look at some of the degrees. This person has a PhD in computer science, a bachelor's degree in cognitive neuroscience, a PhD in organic chemistry, a PhD in applied mathematics, a bachelor's degree in mathematics, a bachelor's degree in physics, and a master's degree in computer science. This one has a bachelor's degree in mechanical engineering, and this one has a bachelor's degree in mathematics and a master's degree in theoretical mathematics. All these people have worked on the same TV show. I'm going to actually take a moment, think about what show that is, and make a prediction. Okay, so I sort of told you to pause the video and think about it, but that's okay. So what do you think? Let's take a guess. How about Jeopardy? No. Good guess. A lot of smart people have to work on Jeopardy because they come up with a lot of really intelligent questions, but not Jeopardy. Somebody said Big Bang Theory. Another good guess. But no, these are not people who work on Big Bang Theory. In fact, these are people who have worked on what I believe is the longest running fiction TV show in the United States. Okay? And yes, of course, I'm talking about, let me advance it, The Simpsons. Wait a minute, duh. Okay, sorry, I have to fix something. That's much better. Okay, so all these writers have worked on The Simpsons. In fact, it turns out a lot of people with advanced degrees in science and mathematics have worked on The Simpsons. Okay, I found that out because recently, over break, actually, I've been reading a book. Okay, no, not that book. This book. I've been reading this book. This book is about the way the writers of The Simpsons have been over the last 26 years that the show has been on. Yes, it's been on for 26 years. How they've been working into all sorts of mathematical references, mathematical principles, a lot of math jokes, and things like that. So I just want to share a couple of examples with you, share with you maybe a couple of problems, see if you can work those out. And maybe next time you're watching The Simpsons, you'll catch some of these. All right, so first, we want to go back to the show Marge and Homer Turn a Couple Play. This is from 2006. Maybe the oldest of you were born right around that time. Okay, but it's set around a baseball game that Marge and Simpson go to. And the key is this jumbo vision. Because at one point is what happens a lot of times in sporting events, the jumbo vision puts up a couple of different numbers for the number of people in the crowd and asks the people to make a guess. And in this episode, when the jumbo vision does that, these are the numbers that come up. 8,128, 8,208, 8,191, and of course, option D, no way to tell. So these look just sort of like three random numbers for maybe a good size minor league baseball crowd. But they're actually three very unique numbers. And they're three numbers that all have different, very special properties in the world of mathematics. So let's take a look at each of them. Okay, let's start, however, with the middle one, number 8,208. 8,208 is what is called a narcissistic number. Okay, now, some of you may be wondering, first of all, what does the word narcissistic means? Well, narcissism is when you have an inflated self of self-importance or admiration. I'm so great. I'm the best. You know, everybody needs me. You're very narcissistic. You're very full of yourself. That's what narcissism sort of means. Okay, and 8,208 is a narcissistic number. Okay, and the definition of a narcissistic number, well, first you start with the four digits in the number, 8, 2, 0, and 8. Now, since there are four of them, you raise each of these numbers to the fourth power. Now, after you've raised these numbers to the fourth power, the next thing you want to do is you want to add them together. And guess what? When you add 8 to the fourth, plus 2 to the fourth, plus 0 to the fourth, plus 8 to the fourth, it's 8,208. The number is literally full of itself. Okay? Again, what happens is you take the four numbers, 8208. Since there are four of them, you raise each to the fourth power, you add them together, and you get that number. That is a narcissistic number. Okay? All single digits are narcissistic numbers. I mean, 4, there's only one digit in 4. 4 to the first is 4. 5, there's only one digit in 5. 5 to the first is 5, and so on. Okay, so those are sort of, not a big deal. The smallest narcissistic number is 153. Now notice there are 3 digits. So I should say the smallest non-one digit, the smallest multi-digit. There are 3 digits, 1, 5, and 3. So there's the 1, there's the 5, there's the 3. Since there's 3 of them, you raise each to the third power. Okay, and 1 to the third power, plus 5 to the third power, plus 3 to the third power is 153. The 2 largest narcissistic numbers are each 39 digits long. And there are actually only 88 narcissistic numbers, and I believe it's been proven that there can be no narcissistic numbers larger than a certain point. So that is, I believe, a finite group, in that there's only going to be 88 narcissistic numbers. So 8,208 is a really cool number in that regard, because it's narcissistic. Okay, so 8,191 is a Mersenne prime. Now, those of you in 5th grade this year, those of you who are in 6th grade now, I talked to both of your classes this year and last year about Mersenne primes. Some of the others of you, I might have talked to you about various points about Mersenne primes, which is a really special group of prime numbers. Prime numbers, you'll recall, are numbers that only have 2 factors, 1 and itself. 7, for example. The only way you can multiply 2 whole numbers to 7 is 1 times 7, so it's prime. 13, 1 times 13, 13 is prime. Well, 8,191 is a Mersenne prime. Mersenne primes fit a certain pattern, 2 to the power of p minus 1, where the number p is actually a prime number. So 8,191 is 2 to the 13th power minus 1. A moment ago, I did point out that 13 was a prime number. So 2 to the power of 13 is 8,192. You subtract 1, you get 8,191, which is a Mersenne prime. Mersenne primes are named after an old French mathematician, Marin Mersenne. And as I told some of you before, that there's actually a whole internet search to try to find large Mersenne prime. And I may have larger Mersenne primes. I mean really large Mersenne primes. There are only 51 known Mersenne primes. Okay, there may be more. Mathematicians have proven that there is no limit to prime numbers. Okay, so there's only 51 known Mersenne primes. The largest is 2 to the power of 82,589, 933 minus 1. Yes, that means you have to multiply 82,589,933 twos and then subtract 1. You can check to make sure that's correct if you do it, because that number itself is just under 25 million digits long. Okay, a single number, 25 million digits long. Okay, to put that in perspective, the entire Harry Potter series of books, all 7 books, have a total of 1,084,170 words. If there are approximately an average of 5 letters in each word, there are as many digits in this one number as there are in 4.5 series of Harry Potter books. So picture all 7 of those books, pick another group of 7 of those books, another group of 7 of those books, another group of 7 of those books, and then maybe about 3.5 or 4 of those books. That's how much paper you would need to print that single digit. So Mersenne primes are really pretty cool. And so that's C. So again, B was a narcissistic number, C was a Mersenne prime, and A is the one I'm going to probably focus on and maybe have a little challenge activity. A is what's called a perfect number. Okay, so you're probably wondering yourself, what? Aren't all numbers perfect? No, actually they're not. There are only so many perfect, well, there could be an infinite number of perfect numbers, we're not sure. But a perfect number is a number whose factors, other than itself, add up to that number. So take a moment, remember what factors are. Factors are two numbers that multiply to another number. For example, factors of 8 are 1 and 8, because 1 times 8 is 8, and 2 times 4, okay, because 2 times 4 is 8. So 8 has 4 factors, 1, 2, 4, and 8. Well, if I get rid of the number that's itself, that leaves me 1, 2, and 4. 1 plus 2 is 3. 3 plus 4 is 7. It does not add up to 8. But if you actually took all the factors of 8,128 and added them together, you would actually get 8,128. That's down here in this corner. I'm going to hide my picture for a moment. And there it is. There are all the factors of 8,128. 1, 2, 4, 8, 16, 32, 64, 127, 254, 508, 1,016, 2,032, 4,064, and you get 8,128. Okay. The smallest perfect number is 6. Notice the factors are 6 of 1, 2, 3, and 6. 1 times 6 is 6. 2 times 3 is 6. If I add up anything except for 6, 1 plus 2 plus 3 equals 6. Now, here's where things get really interesting. Okay, there are actually 51 known perfect numbers. That number 51 ring a bell? That's actually the same number of Mercian primes. In fact, there is a connection between perfect numbers and Mercian primes. If you know the power a Mercian prime is raised to, you can actually calculate a perfect number. If you know a perfect number, you can actually calculate a Mercian prime. That is really pretty cool. Again, the first one is 6. The third perfect number is 496. 1 plus 2 plus 4 plus 8 plus 16 plus 31 plus 62 plus 124 plus 208. And that's number 8,128 is the fourth perfect number. So this brings us to your first challenge. So your first challenge is to find the second perfect number and show that it is perfect. You show that it's perfect by showing all its factors and adding them up. Now, here's a hint. The second perfect number is 2 digits long, and the digit in the tens place is less than the digit in the ones place. Okay? There's another little hint here. There are no known odd perfect numbers. So that narrows it down. So there's your first challenge, which is find the second perfect number. The first perfect number is 6. The second perfect number, I forgot already, was I think 4,496. The third was 8,128. The second is somewhere within these parameters. Okay, I'm back, and it's time to move on to another episode and another set of mathematical advantages. And this is the last episode of the 2015 season, which is called Mathlete's Feat. Okay, Mathlete's Feat centers around a math competition. Math counts, guys. A math competition in which the kids from Springfield go against kids from another school. A lot of interesting stuff happens, but there's a lot of mathematical jokes in this. Starts actually with the t-shirts that they're wearing. Notice the equation on the t-shirt. Pi is not equal to A divided by B. Now, those of you, I believe, in 7th and 8th grade up, we've talked about what are rational numbers. Rational numbers are any number you can write as a fraction, which would be, for example, A over B. Pi is irrational. You cannot write pi as a fraction, so hence the little fraction type joke there, that pi is not equal to A divided by B. Then a couple moments later, they walk in, and there's this sign right outside the door. Today's math joke, and it has these different symbols, which you may not know what all of them refer to. Well, in mathematics, the square root of -1, this first one, is defined by the letter I. So square root of the letter 1 is often defined as the letter I. 2 to the third power, well, it's 2 times 2 times 2. 3 2's, 2 times 2 is 4, times 2 is 8. So 2 to the third power is 8. The Greek letter here, okay, Greek letter sigma here, In mathematics, that refers to a sum. You do that when you're adding up a series of numbers. So that refers to sum. 2 to the third is 8, and -1 is I. And then, of course, this last symbol we saw in the previous slide is the number pi. So today's math joke is I ate some pie, and it was delicious. A lot of people probably watched that episode, went right by this scene, having no idea what it was referring to. I think it's pretty clever. Okay, so at the end of the episode is a challenge, a final question. Okay, it comes down to one question between the kids from Springfield and the kids from whatever that other school was. And the question was, you take this drawing, which is the letter M, and draw 3 lines to create 9 non-overlapping triangles. Okay, and I'm going to pull up a pen here for a moment to show you what I mean. So you got to draw 3 straight lines. So I'm going to draw, say, 1 line here. Now, if I draw 1 line here, notice I create 2 triangles. There's a triangle, and there's a triangle. Now, if I tend to draw another line here, now obviously I create a triangle here. So there's 3. Now, some might be saying, well, wait a minute, notice if you go like this, that's a triangle? Yes, it is a triangle, but the challenge is non-overlapping triangles. This blue triangle overlaps that green one. So that's the challenge here. Okay, and that brings us to challenge number 2. Challenge number 2 for you is to draw 3 straight lines to create 9 non-overlapping triangles. So what you can do is you can get a piece of paper, you can draw it out, take a screenshot of it, okay, submit it to your teachers. Okay, either put it in Google Stream, email it to your teacher, however you'd like to share it. Okay, so that's challenge number 2. Challenge number 3, I'm just going to get to right now. Very simple. How many different shirts did I wear while doing this video? If you've been paying attention, I've been changing my shirt throughout this video, wearing a different color every so many slides. So how many different shirts was I wearing? And what color was a shirt that I wore backwards? So you have 3 questions. Find the third perfect number. Try to make the 9 non-overlapping triangles from the letter M. And what color, or how many shirts did I wear, and what color was the one backwards? I mentioned earlier, there's lots of imaginary bonus points available. In fact, there's 1 million imaginary bonus points available. It'll be divided among anybody who gets all 3 questions right. So if only one of you gets all 3 questions right, you get those 1 million imaginary bonus points that are really completely worthless. Okay? If 2 people get it right, then you've got to split the points and you each get 500,000. If this video goes viral, and I expect it will, why wouldn't it? It's really cool. And 1 million people get all 3 questions right, then they each only get 1 point. Okay? So you can email your solution to your teacher. Okay? You can post your solution in Classroom Stream if you want. Okay? And don't consider this necessarily homework, but it's something we'd like to give it a try, have a little fun with this, and enjoy a little bit of sort of a fun way of looking at math. Okay, so I hope you enjoy this presentation, and looking forward to seeing you tomorrow and next Wednesday for next Wednesday's Wonderful Wednesday. Have a good day.